and welcome to the video. In this video, we are going to talk about describing a transformation. So when you're asked in your exams or tests to describe a transformation, you have four options. When you're asked to describe a transformation, it's going to be one of the following four things. So in the branch of mathematics that we call transformations, certainly for your tests at this point in time, your four options would be, it could possibly be a reflection. So the movement of the shape, the transformation of the shape could be a reflection. The transformation of the shape could be a rotation. The transformation could be an enlargement, or the transformation could be a translation. So when you're asked to describe a movement or a transformation of a shape, chances are you're going to need to highlight one of these four options. Once you've highlighted one of these four options, you need to give a little bit more detail about how the transformation took place. So the examiner will be looking for certain important bits of information that you're able to give. So of course, your first mark will be for identifying whether it's a reflection, a rotation, an enlargement, or a translation. If you decide that the movement, the transformation, is a reflection, you also need to tell the examiner the mirror line that is the line of reflection. So your reflection may have occurred in the line x equals 2, or y equals 4, or y equals x, or any linear line, linear graph. So you're giving the equation of the mirror line. So if you're asked to describe a transformation and it is a reflection, you state that it's a reflection and you also give the equation of the mirror line. If you decided that your transformation was a rotation, the additional information you need to give are the three things I've highlighted in blue here. You need to give a center of rotation, so you need to give some coordinates where the rotation originated. A direction, are you going to go clockwise or anti-clockwise? And then also the size of the rotation. Is it a 90-degree turn or a 180-degree turn? Or you may explain the turns in terms of fractions, half turn, quarter turn, etc. So for a rotation, you need to give three additional bits of information. If you decide that the transformation is an enlargement, what the examiner would expect to see is that you've highlighted the center of enlargement and you've also explained what the scale factor is. So you may be dealing with a scale factor of 2 or the scale factor of 1/2 or even a scale factor of -3, something like that. So if you decide the transformation is an enlargement, you're giving an extra 2 bits of information, center of enlargement and an appropriate scale factor. If you decide that the transformation is a translation, then you need to give a little bit more information to the examiner. I would always use the word vector just to show a good understanding. So I would be saying that the transformation is a translation by the vector, and then I would state the vector. So your vector will look something like this, with the top number telling you your right or left movement and the bottom number telling you your up or down movement. So if you're explaining the transformation as a translation, I would be using the word vector and then also stating the correct vector. As we work through the slides and you have a go at the task at the end of the video, you may want to come back to this slide just as a summary of what you need to present when you're describing a transformation. Okay, so let's have a look at a few examples. Describe the transformation from the blue shape to the red shape. So we're going from blue shape to red shape. So first of all, I need to decide, is it an enlargement? Is it a rotation? Is it a reflection? Or is it a translation? So we're ruling out enlargement because it's not any bigger. We're ruling out reflection because the shape has not been flipped or altered. It also doesn't appear to be a rotation, so it looks like it satisfies the idea of a translation. I'm moving the shape from here to here. I'm sliding the shape from blue to red. Very important that we read the order of the question as well, because possibly this question may have had red and blue the other way around, which would then have resulted in you going from red towards blue. So first of all, I'm going to state that this is a translation. I've picked up 1 mark. But then I also need to explain the translation. So I know I'm going to say it's translated by a vector. There's my key word, vector. And now I need to decide on my vector. If I take this point on the blue shape, and I'm going to try and get to this point on the red shape. So I'm going to go 1, 2, 3, 4, 5, 6 to the right, and 1 down. So that's going to result in a vector of 6 minus 1. Reason we're using -1 is because on the vertical movement we went 1 down. We did not go 1 up. Let's just double check that movement. I'll go from here to here. So I'm going to go 1, 2, 3, 4, 5, 6 along and 1 down. So there is my description of the transformation that took place. I would say that moving from the blue shape to the red shape, I have used translation, and I've translated by the vector 6 minus 1. So you would probably end up giving those bits of information in a sentence. A translation by the vector 6 minus 1. Let's have a look at another question. Describe the transformation from blue shape to red shape. So again, we're going from blue to red. Still not an enlargement because the shape hasn't changed size. I'm going to rule out transformation this time because the orientation of the red shape is different. This time it has been flipped, which is suggesting it is a reflection. So I'm going to state that to get from the blue shape to the red shape, we are carrying out a reflection. If I decide it's a reflection, I also need to comment on the mirror line. I need to give the equation of the mirror line. So this blue shape is reflected in this line here. So this line here is, of course, the y-axis. So this line here is the y-axis. The y-axis is also known as the line x equals 0. So what I would be stating here is this transformation is a reflection in the y-axis or the line x equals 0. So I've stated my transformation, and I've also give some information about the mirror line. I just wanted to check, if I take this point on the shape, you can see I go 2 squares to get to the mirror line. Then if I go another 2 squares, I'll get to the corresponding corner on the image, on the reflection. Let's try this point here. From here towards the mirror line, 1, 2, 3 spaces. So then if I go 3 spaces from the mirror line, you can see I land on the corresponding corner on the reflection on the image. This time we are still going from the blue shape to the red shape, but this time it's quite obviously an enlargement. Our image, our red shape, is bigger than the blue shape that we started with. So if we're wanting to describe this transformation, first of all, I'm going to state that it is an enlargement. Then I also need to find out the scale factor and the center of enlargement. For the scale factor, if I pick a side of the original shape, this side here, you can see it's 2 squares along. And if I look at the corresponding side on the red shape, it is now 4 squares along. So I've went from 2 to 4, which means I've multiplied by 2, which is telling me that my scale factor is 2. Let's try another side. If I was to take this side here, you can see it has a height of 1 square. And if I look at the corresponding side here, it has a height of 2 squares, which is telling me that the scale factor is 2. So I can confidently state that I'm dealing with a scale factor of 2. Every side on the original shape has been doubled in size for the image, for the red shape. Okay, we also need to state the center of enlargement. Sometimes you can do this by inspection, but sometimes this can become a little bit tricky to find the center of enlargement. This is how I would go about finding a center of enlargement. With your ruler, I would find a point on your enlarged shape and draw a line to the corresponding corner on your original image, and then continue the line on. And I would do that for a few different corners. So if I take this corner, draw a straight line to the corresponding corner, and then continue the line on, you can see that these two lines meet at a certain coordinate. If I take this corner here, draw a line to the corresponding corner, and then continue it on. We'll just do one more. This corner here to the corresponding corner, and then continue it on. And you can see that all of my lines meet at the coordinate -5, -3. So I've used my ruler to work out an accurate center of enlargement. So I'm stating that my center of enlargement is at -5, -3. So there is my 3 important aspects of describing this transformation. I've stated that it's an enlargement, I've worked out it's a scale factor 2, and I've used my ruler to accurately find the center of enlargement, which is at this point here, -5, -3. In this example, we are still trying to get from the blue shape to the red shape. What transformation has took us from the blue shape to the red shape? So this time you can see the orientation of the red shape is a bit different. So that is suggesting that the transformation I'm applying is a rotation. So once we've decided it's a rotation, we also need to state the direction of the rotation and the size of the rotation. So are we dealing with a 90-degree turn, or a 180-degree turn, or a quarter turn, or a 3/4 turn? So we also need the size of the turn, the size of the rotation. Usually in your tests and exams, you'll be able to answer these questions by inspection. So just by looking at this question, you can see that the center of rotation is actually going to be at the origin 0, 0. So you can see that this shape, if we were to place our pencil here and rotate the shape using tracing paper, it would land onto this shape. So I'm just going to state that this is a 90-degree turn, which we could also call a quarter turn, and it is in the clockwise direction. And I am stating that the center of rotation is at 0, 0. So from the blue shape, I've rotated 90 degrees clockwise to land on the red shape, and my center of rotation is at 0, 0. When you're doing these on paper, obviously you'll have the aid of tracing paper. So if you were unsure where the center of rotation was, you could lie your tracing paper over the shape, place your pencil on where you think that the center of rotation is going to occur. Then you could try out the rotation to see if your shape lands where it should. If it's correct, great, you found the center of rotation. If it was incorrect, you then go ahead and try another point. You could also have stated this rotation as a 270-degree anti-clockwise rotation. But when we're describing a rotation, we would usually look for the quickest or the smallest turn. So what is the smallest turn that would take us from the blue shape to the red shape? Okay, I just want to look at the idea of finding center of rotations in a little bit more depth, because I think this is probably the trickiest aspect of describing transformations. So I'm just going to give you a few ways or a few ideas of how you could find the center of rotation if you're struggling to find it by inspection. Okay, so if I was to look at this shape and I wasn't sure when the center of rotation was going to occur, I'm going to sort of extend the idea of inspection, of inspecting for the center of rotation. I'm going to highlight a point on this shape. So I'm going to go for this point here. I'm going to highlight the corresponding point on this shape. So even though the shape's orientation has changed, this point, or the point I've highlighted on the blue shape, would now be this point on the red shape. I'm just going to highlight those a little bit easier to see in green. So I'm moving from here to here. So I could have done this with any point. So now what I'm thinking of, again, just extending that idea of inspection, is if I was to go one along and one down from this point green, one along, one down, and then if I just think about rotating this little right angle here, this dotted green right angle that I've created, if I was to rotate that 90 degrees clockwise from the point -1, -1, you can see that's where it would end up. So this was my original dotted green line here. And from this point at -1, -1, I've rotated it to now stand here. So it's now here is the image of my dotted green line. And that takes me to the corresponding corner on my new shape. So this is just a way of extending that idea of inspection. If when you first inspect the question, it's not totally clear where the center of rotation would be, you could approach it in this manner, thinking about, okay, so I've got one step to the right and one step down, and if I rotated that movement, would I land on the corresponding corner on the new shape? So now I can go ahead and explain this transformation. We know it's a rotation and we're going 90 degrees in the clockwise direction. Again, it's a quarter turn in the clockwise direction. And this time our center of rotation is going to be at the point -1, -1. So we've just extended that idea of inspection in order to find the center of rotation. In this example, I'm going to talk through an alternate way of finding the center of rotation, a more mathematical way of finding the center of rotation. So if you're struggling to find the center of rotation by inspection, you could have a go at using this method to find the center of rotation. This is actually a bit of beautiful mathematics. It brings together 2 or 3 different topics of maths in order to get a result. So if you're finding this topic a little bit tricky, and a lot of students do, because finding the center of rotation from inspection can be sometimes quite difficult to visualize, quite a difficult concept. So you could go ahead and attempt to find the center of rotation using this method. Okay, so you can see from the question, we're still aiming to go from the blue shape to the red shape. So we're transforming the blue shape and it is resulting in the red shape. So we can see from the orientation of the red triangle that we're dealing with a rotation. It looks as if it will probably be a quarter turn, a 90-degree turn in the clockwise direction, but I'm going to wait to confirm that after I've found the center of rotation. Okay, so for my new method, you can see that I've identified and highlighted some corresponding angles on each triangle. So this angle corresponds to this angle, and this angle corresponds to this angle. So I'm just going to match up those corresponding angles. So I'm just going to, with a straight line, with my ruler, I'm just going to match up this angle to its corresponding angle. And then with my ruler, I'm going to match up this angle with its corresponding angle, like so. So we've taken two pairs of corresponding angles from the original shape and the image. Then what we're going to do is each of these blue lines, we're going to find the perpendicular bisector. So we're going to find the line that cuts this blue line exactly in half and also creates a right angle to show that both lines are perpendicular. So you would go ahead and use your knowledge of constructions, using your compass and drawing on a few arcs to find accurately the perpendicular bisector. So if I look at this blue line first, my perpendicular bisector is going to go somewhere like there. Okay, so if we look at this blue line here, you can see that the dotted green line cuts the blue line exactly in half, and we also create a right angle at this point, proving that the two lines are perpendicular. So you would have found this green dotted line using your knowledge of constructions and placing your compass at different points to find the perpendicular bisector. Then separately, I'm going to look at this blue line, and I'm going to also find the perpendicular bisector of this blue line. Again, you'd use your compass, but for me, I'm just going to place the perpendicular bisector there. So if you look at this blue line, you can see that my green dotted line cuts the blue line exactly in half. So we have a perpendicular bisector cutting this blue line exactly in half. So now what we're interested in is, where do these two perpendicular bisectors meet? So if we look, we can see that both green dotted lines cross at this point here. And this is the point we can now accurately say is the center of rotation. So now it's a bit easier to say that I'm dealing with a 90-degree rotation in the clockwise direction. So to get from this point to this point, or from this point to this point, we're rotating 90 degrees in the clockwise direction. Remember, we could also state that it was an anti-clockwise rotation of 270 degrees, but this would be a more appropriate answer. And then we can also confidently state that the center of rotation is at the coordinate -1, 1, because it is at the point where both perpendicular bisectors intersect, where they both cross. And this method will work for any rotation. So as soon as your questions start to get more complex, start to get more difficult, and finding the center of rotation from inspection is no longer possible, then this bit of beautiful mathematics would help us find our center of rotation accurately every time. Okay, so now it's your turn to have a go at a few questions. I've put 9 transformations on the screen. I would like you to pause the video, and for each of the transformations, I would like you to fully describe the transformation that has occurred. So for each of these questions, could you identify whether you're dealing with a translation, an enlargement, a rotation, or a reflection? And then depending on which of the 4 options you choose, could you then go ahead and describe the full transformation? Just like in my examples, we're going from the blue shape to the red shape. That's very important. Could you have a go at all 9 questions? Could you pause the video now, please? Okay, welcome back. And here are my solutions. So you can see from my 9 answers that there wasn't actually any enlargement questions to be identified, but you did need to decide if we are dealing with translation, reflection, or rotation. And then once you decided that, you would go ahead and give me the full explanation, either by giving me the vector, maybe the equation of the line, or describing the rotation and the center of rotation. Very well done if you were able to get all 9 correct with full explanations of how those transformations occurred. And here's the last question for you to have a go at. So this time I put a transformation on the screen. As always, we're going from blue shape to the red shape, but this time it's a bit of a challenge question. I'd like you to describe this transformation in 4 different ways. Can you explain to me how I could move this shape from the blue square to the red square, but in 4 different explanations? So a bit of a challenge question here. Could you pause the video at this point, have a little think about this question, and then I'll talk through my solution in a moment. Could you pause the video now, please? Okay, welcome back. So let's talk through a few of the possible answers you could have given. To start with, we could have said that this is a reflection in the y-axis, or the line x equals 0. So we are dealing with this line here. We have a reflection from the blue over to the image. So we could state it was a reflection in the y-axis. We could have called this a rotation by 90 degrees in the clockwise direction from a center of rotation at 0, 0. So if this was your center of rotation, the origin, this shape has been rotated 90 degrees in this direction. Remember, we could also have described this as an anti-clockwise 270 degree rotation. So there's a further explanation we could have given. We could have also called it a translation by the vector 4, 0. If I pick this point, I'm going to go 1, 2, 3, 4 along and 0 up or down to land there. So we could have also explained this transformation or described this transformation as a translation by the vector 4, 0. And the difficult one to identify is that we could also have stated that this was an enlargement by the scale factor -1 from a center of enlargement of 0, 2. So if I was to say my center of enlargement was here, and if I was to draw on some straight lines, remember we're dealing with a negative enlargement in my justification here. So you come out the opposite side of your center of enlargement. So if I was to match up all the corresponding sides, you can see that the center of enlargement would occur at 0, 2. We come out the other side of the center of enlargement because of that negative scale factor. So there's at least 4 ways to explain this transformation. We could have also had a rotation of 180 degrees around the point 0, 2. So there's a further description of the transformation that could have occurred. Very well done if you were able to identify these transformations. That's brilliant. That's showing a very good understanding of describing transformations. Well done.